that, let's get started with our today's presentation of deploying AI models using OpenVINO by Anisha Udayakumar. She's a AI software evangelist at Intel. With that, over to you. Thank you.
Thank you, Monica. Thanks for giving a brief introduction. So I guess without much further ado, let's get started. I hope my screen is visible. Yeah.
We can hear you. We can see it.
All right. So yeah. So hello, everyone. Very good morning, good afternoon, or good evening, depending on where you're joining us from. Thank you so much for taking the time to be part of today's session. And I'm really thrilled, to have the opportunity to speak with you all today. It's always a pleasure, connecting with fellow developers and enthusiasts in AI community. So today, my session is mostly going to be technical. So coders out there, the session is completely for you. So yeah. All right. So let's get started. What you see here is the survey code. I would really appreciate if you could save a few minutes at the end of today's session to share your thoughts and experiences, which helps me to improve and my team to bring you the most valuable content and insights in our future webinars. I guess we have another webinar coming up soon, like Monica mentioned. So once again, I would like to thank you for joining in today's session. I would like to again introduce myself. I'm Anisha Udayakumar, and I'm an AI software evangelist from Intel. My core mission, I'm deeply passionate about, is to support and empower developer community, and my day-to-day work is around engaging developers, creating technical content, especially around toolkits like OpenVINO and others to enhance their journey in AI. So I believe that by equipping, developers with the right tools and knowledge, we can collectively push the boundaries of AI. I'm sure all of you would be agreeing with me. And I'm proud to be part of a global team that you see here. We are a team of AI evangelists. We are stationed in every corner of the world, each of us dedicated to assisting developers in harnessing the power of OpenVINO. And yeah, today's session, deploying AI models using OpenVINO. I would quickly like to ask a question, like how many of you are coders are into AI development? And if so, what is your favorite AI framework and the language that you code in? This is just for me to get to know how many of you are Python developers, C or C++ developers, and others in the group. So our focus will be on how we can leverage toolkit like OpenVINO that can empower developers, really efficiently in transitioning from not just AI development, but till AI deployment across various platforms. By platform, I mean we have so many devices here today. I'm going to focus on how you can leverage all this in your AI development until you deploy your AI solution. In this context, I would like to mention the role of AI PCs today. With the advent of AI everywhere, these advanced computing solutions optimized for AI tasks are becoming increasingly vital for developers. They offer the power of flexibility needed for all the cutting-edge AI development and deployment, as I mentioned. So we are all AI developers who face challenge almost every day as we code. Often we get into this hurdle of maintaining code that is compatible across diverse architectures, right? A task that can be as complex and it is a very, very critical thing when it comes to development. So we'll try to demystify what are all the challenges that we face. For example, if we'll have to, implement and run popular and cutting edge AI use cases that are built on sophisticated models like stable diffusion. If you do not know what stable diffusion is, it's one of the AI model where you can just input text and it'll give you stunning visuals. And other popular business models that are used for object detection use cases like YOLO and others. How can you run these effectively and efficiently? That is always a challenge for an AI developer. We'll try to explore what are all the strategies and tools that can streamline these cross-architecture code management, right? I guess this is one of the nightmare that every AI developer has. It's very easy to develop a POC that can, give a solution for the real world business problems, but scaling it up is a real challenge. Um, and as I mentioned, like we developers are like superheroes, right? We would have already developed the AI model, but developing an AI model, training it with the right data, and having it ready is just solving 50% of the problem. And the rest, if you see, majority or like the last mile is covering the deployment, which is very, very critical when it comes to actually professionalizing an AI solution. And as I mentioned, we developers are real superheroes, right? We try to pick a real world problem, try to solve it, and we have the AI model ready in our hand and assume that it has 99 to 100% accuracy. What next? How would you like to, deploy your neural network? Again, you can answer in the chat, maybe. How would you like to, deploy the neural network that you have built? On which device and why? Um, I'll try to see if any of you have answered. Yeah, so keep them coming, keep answering. Um, I'm sure your answer would be like one of these devices, right? All of us have CPUs with us and some GPUs and some edge devices as well. If you're an edge developer, then there'll be edge devices with us. And if the business needs requires any of the specific devices, then we would love to deploy our neural network on that device. It can be CPU, GPU. We have a common term now called XPUs. It can be anything. But when it comes to deploying across these devices, we have so many questions, right? As developer, we face so many challenges if we'll have to make the AI model work on across these platforms. And not just that, even if you have identified which device you'll deploy, we will still have a lot of questions popping up our mind if we'll be able to, get the best performance out of, the available hardware that we have shortlisted. How are we going to maintain the code across these different architectures, and how to get the most out of it, or get the cutting edge solution out of it? And the answer to all of this, or the solution that I would like to propose, or one of the solution can be a toolkit like OpenVINO. OpenVINO stands for Open Visual Inference and Neural Network Optimization. It's not just for computer vision, but it is also for NLP, Gen AI models. Now we have the most buzzing LLM models as well. So OpenVINO supports all of this. Yeah. Not just that, let me just quickly tell you how a developer journey with OpenVINO looks like. First, you have your or developed your AI model. Then you optimize it with OpenVINO, and then you deploy it across devices. What it means is, as a developer, you would have developed your solution in one of these popular AI frameworks. PyTorch and TensorFlow would be a go-to option for many of you. And based on the model you choose, again, the AI, you drill down to one of these AI frameworks. It can be PyTorch, TensorFlow, Keras, Onyx, Paddle, and there are many more. With that, you try to optimize your model using OpenVINO and deploy it across the spectrum of hardwares, specifically Intel hardwares like Atom, Core, Xeon. The most recent one that has been released a couple of days back is Intel Core Ultra, the AI PC that I was talking about. We also have discrete GPUs. I don't know how many of you are aware of the fact that Intel has discrete GPU. We also have integrated GPU and NPUs, neural processing units, which are specifically built for AI workloads, and FPGAs as well. Not just that, no matter which operating system you have, like Windows, Linux, or Mac, you'll be able to install OpenVINO and optimize your model. Let's quickly see what are all the latest features that we have in our release. 2023.2 is our latest published release. We are heading towards 2024 release, which will have much more exciting features. But in this latest release of OpenVINO 2023.2, we have extensive supports like model supports like TensorFlow front end, PyTorch front end, ARM processes, and so on. We optimized the model and extended the support to many Gen AI models, and also all the new models that is coming into on our everyday daily basis. Like every hour we see a trending model coming with new benchmarks, right? We try to support most of them, which are like quite popular, trendy, and most useful for businesses. Not just that, when it comes to deployment, there are like many factors. When you're deploying it on a hardware, we try and have functions, properties which can help you utilize the best of the resources that you have in the device when you're running an AI model on it. We will see in detail in today's session. Again, I'm warning you, this is going to be more technical. For those of you who love technical, this is a session for you. So just an icebreaker question again. So you see video, right? I'm sure most of you are thinking like these two are same videos. Again, the game is to find the difference between these two. So I'm sure if you want to answer what kind of AI model it is, what is the inference that you're seeing here? When I mean AI inference, it's like the output that the AI model gives. So here you see points being detected on a human body, right? What do you think is this model doing? Probably I can give a couple of minutes for you to answer this question. I'm trying to keep it as interactive as possible. So if any of you know what kind of model this is, please feel free to answer that in the inbox. So for many of you who don't know, this is post estimation or key point detection. What's happening here is if you're not unable to spot the difference, there are some of the metrics that are being displayed here: inference time, frames per second, and the model size. 16 MB is the model size, that's on the left, and 4.7 MB is on the right. So if you ask me which is the best model, obviously it's on the right, because the model size is smaller, the inference time is faster, and the FPS is higher, which is like close to 90 FPS, which is really, really good, which means it's giving you real-time inference, which means the output is really instant. It's not taking a lot of time. So this is what I meant by optimizing your model for better performance. So you're trying to improve or make your model run faster, make it lighter, and get the fastest inference possible. And that's the ultimate goal of using these kind of AI optimization tools during deployment. So let's deep dive. Now that you know what OpenVINO means, if you have this question as to how or where can you get started with, all you'll have to do is just get started with installing OpenVINO. And you can install OpenVINO through these package managers. like Yum for Ubuntu, app for Red Hat. You can also install it through Docker, Conda, and CC++ package managers, Karan. And if you want to know more about OpenVINO or deep dive into the topic, please feel free to scan the QR code or go to openvino.ai. And if you're a Python developer, the easiest way is to pip install OpenVINO. So if you ask me what's within this toolkit, one of the major component is OpenVINO model converter. So I mentioned about having the AI model in one of those format like TensorFlow, which is .pb or PyTorch or others. You use this model converter API, optimize it to OpenVINO format or IA format. We call it intermediate representation format. The IA files consist of .xml and .bin file. .xml hosts the architecture of the model and .bin file hosts the weights and biases. You optimize the model to FP16, floating point 16 of floating point 32 format. So what it means is you're trying to optimize and convert your model into a lighter version so that you get best performance out of it without compromising much on the accuracy. So these are the syntax that you'll use. And as I mentioned, we also support PyTorch model for torch vision. This is the code snippet. Similarly, we also support TensorFlow, TF2, Keras, and Paddle models as well. So when you use model converter API, this is how you can visualize. Imagine your native model has these many layers. Post optimization, the layers gets reduced, the unnecessary layers are removed, and the model gets much more simpler, and so you achieve faster inference out of it. And the OpenVINO runtime looks like this. First, you import OpenVINO, and then you load the data. This is an example for image classification model. And then you initialize the OpenVINO runtime. You read the model. It can be in IA format or any other AI framework format, because with the latest release, we support directly other front ends as well. You compile your model, and then you get the output layer through the compiled model, and then you try to get the result by sending the output layer into the compiled model. So with just few lines of code, you would be able to tell if in an image, if there's a cat or dog, as simple as that. So this is how it looks like for a TensorFlow automatic conversion. All you see is the difference in the fourth line of code, which is like .pb or .tf or .onyx, and so on. The rest of the code remains the same. And this is what I meant by saving developers time and effort. We have the package for you. All the developer will have to do is utilize, write the code once, deploy it across hardwares. They'll just have to spend their time on being creative and building the solution, and the rest is taken care. So this support for PyTorch 2.0 is a game changer for those of you who are working with PyTorch native application, especially when integrating with OpenVINO. So imagine a world where your PyTorch code runs not just efficiently, but at lightning speed. And that's exactly what torch.compile offers. It takes your PyTorch code, which typically runs in what we call eager mode, and transform it using, just in time, JIT compilation into optimized kernels. And this is crucial because boosting performance and making the most of your hardware capabilities is really critical for any developer. And in essence, torch.compile is giving your PyTorch code a supercharge, ensuring it runs not just correctly, but also, exceptionally well. So yeah, if you ask me what are all the devices that we support CPU, we support GPUs, we have discrete GPUs, Flex series, Arc series, Iris, integrated GPUs, neural processing unit, like the ones we have in our Core Ultra. And if you don't know, if there is a scenario where you're running your AI model in, multiple devices, but you don't know which device can get you the best performance, then Auto is your go-to option. It exactly does automatically selects the optimal hardware for your AI workload. And this means you can write your application just once, as I mentioned, and as a developer, you can deploy it anywhere without worrying about the underlying hardware. So Auto defaults to starting inference with the CPU, because with CPUs, they offer low latency and no delay in kickstarting the inference, and that's the reason we have CPU to be picked up when we give Auto. And slowly, if there's GPU, it picks up the best performance out of it and slowly starts moving towards it. So using Auto in OpenVINO simplifies device management, optimizes performance, and ultimately, makes the developer's life easier. And that's always our ultimate goal. And again, you will be seeing more of code today, as I mentioned. This is how cumulative throughput mode works. So if you're building solutions for businesses, there are multiple things that we give priority for. One is throughput, and the other one is latency. And coming to the performance, like I've been talking about optimizing model and improving the performance. How do you mention what is the use of this performance hints, right? That you see in the code snippet. It is, allow you to express your target scenario with just a single config key. The device adapts after that when you mention the hint, optimizing its performance to meet whatever specific need as a developer we have. So it's all about, working smarter and not harder. So as you see here, latency mode is the focus, the major focus is on speeding up the processing time of each individual task, which is really ideal for real-time applications. If you want a real-time inference, then that would be the go-to option. And throughput is all about processing as many tasks as possible within a given time, which is perfect for high-load scenarios. So what happens is throughput mode, you will have to choose, or it might impact your model's load time and memory usage, because throughput mode may take longer to load and consume more memory, whereas latency mode is all about quick task processing. So that's how we play around with the hints based on our business requirements. You tend to choose either throughput or latency, whichever is the best fit. And if you see how we can supercharge all of these AI models, cumulative throughput mode with auto setting is the best. The reason being, imagine there's a situation where you have a powerhouse of like multiple machines, like multiple devices, equipped with Intel devices like CPUs, iGPUs, integrated GPUs, and dedicated GPUs, the DGPUs. Usually when running these AI models, we tap into just one of these. But what if we could harness the power of all of the devices at once, right? That's where cumulative throughput comes into picture. I'll try to keep it as at high level as much as possible, because I'm assuming that we are all at beginner level of development or developers. So we are heading towards the most exciting part, which is the hands-on session. So if you see, we have our OpenVINO notebooks, which is completely open source for developers to play around with. All you'll have to do is scan this QR code and explore. It's GitHub and publicly available, or just go to Google and search for the keywords OpenVINO notebook GitHub, and you'll land here. And if you want to install and get your hands dirty with playing around with the Jupyter notebooks, all you'll have to do is just 4 steps: clone the repository, and create the environment, install all the requirements and dependencies, and that's all. You can launch the notebook and you will see how you can run the code. As simple as that. So this is how it will look. It's very easy for any developer to play around with. So today I would like to show you a couple of notebooks, the basic ones. If you are a Gen AI or LLM expert and wanted to know about it, please join the next workshop series. We'll be deep diving into it. Here today, first let's see the segmentation notebook, where you'll be able to segment the image that has been given. So the core idea here is we are going to pick a segmentation model, optimize it with OpenVINO, as you see here, and then run it across multiple hardwares. I have a CPU and GPU put together, and I'm going to show you how it runs and what is the performance that we achieve from a native model and optimized version of the model. So as you can see, there are multiple steps to it. First, you optimize the model, and then you build the inference pipeline to make the optimized model work. And this is an example for object detection. What you saw there was the .xml and .bin file of the detection model. So again, we first load the model and convert it to IR format, or directly load it into OpenVINO runtime and do the inference like this. And this detection means we are trying to detect the text within the given input image, and it works perfectly fine. There's one other notebook that I wanted to show you, where you will see how we can convert a PyTorch model, a ResNet-based PyTorch model, which does object classification and detection. So as you can see, we are loading the native PyTorch model, and you can see the number 26.8 milliseconds, right? It was the time it took to do the inference. Now I'm trying to convert the model and compile it with OpenVINO runtime and run it across these devices like GPU, CPU, or auto I can choose. And as you see, the object detection, it just took 2 milliseconds against 26 milliseconds. And that's the performance boost that we are seeing. This is the only visible performance, but there are like much more, which you can explore through our performance benchmark app. And there are few other examples of how we are showing, like there are trace models and other models you can explore in detail. The notebook number is 102. The other two notebooks are 003 and 004. So let's move further. I'm sure you would have enjoyed the hands-on demonstration. Please feel free to connect with me. I'm on LinkedIn. If you have any doubt while installing OpenVINO or running these notebooks, or if you need any help in your AI journey as to not knowing how you can leverage OpenVINO, please feel free to reach out to me. And so as you saw, that software optimization part, right? Model optimizer. We also have others like NNCF, Neural Network Compression Framework, which we will explore in a while, with different performance hints. Now let's see how the hardware optimization works. And these will be like some of the major features that came out in our latest release. One is thread scheduling. There are many other features. I'm trying to cover the most useful that I felt would be useful for developers like you. And if you want to, explore in detail, you can go to openvino.ai documentation page or scan this QR code. So coming back to thread scheduling, we all know that efficiency is key, right? When it comes to deploying any solution, and with AI solution, it's all the more important. So multi-threading helps us to boost this, specifically CPU inference. So try to visualize this. You have multiple inputs to process. So multi-threading steps in here, splitting the task across several logical processes. We have P cores and E cores. It's not just about the speed, it's about like smart resource, as I mentioned. earlier, smart resource management. So the key to this process is customization. On hybrid platforms with different core types, you choose which cores to handle the inference. And this is very key. If you are a hardware expert, you will know what kind of liberation this gives you. Previously, it was all a black box, not knowing how we can utilize the maximum of the resources from the hardware that we have. But with these kind of thread scheduling and other features, you'll be able to tap into customizing the full utilization of the resources from the hardwares that you have on upon which you'll deploy these AI models, which is very, very critical. Um, so as you can see, this is like hyper-threading is really useful. And when it comes to thread count, all you'll have to do is set the limit, as you see on the screen, like 4, ensuring your CPU doesn't overextend, striking, we're trying to strike the right balance for the AI workload. So in short, multi-threading in AI is about orchestrating your resources efficiently, and each core and thread plays its part, ensuring that the model runs very smoothly and efficiently. Not just that, as you can see, OpenVINO runtime optimizes performance by default through CPU thread pinning, ensuring we have the dedicated processor time for all the tasks. So this is how it works. And if you disable the CPU pinning, potentially it'll try to improve the overall workflow efficiency. The next key feature is model caching. This is very important if you're using heavy models like transformers and so on. So when you enable model caching, what happens is OpenVINO does something very clever. During the first compilation of your AI model, it automatically creates a cached blob in the specified directory. And this blob isn't just the copy of the model, it's a partially transformed version of your entire neural network, having gone through runtime optimizations, lower precision transformations, and many other optimizations. So the real benefit comes into play when we try to, compile it next time, the second time after that. Instead of starting from scratch, OpenVINO tries to load it from the cache representation. And if you ask me why it is important, those transformation steps which were initially time consuming, for the first compilation it might have taken like a huge inference time, would have completely bypassed. This means your model gets up and runs faster, significantly reducing the first inference latency. And it works like this, as I mentioned. So in short, model caching is the code looks like this. It's all about efficiency and speed, and it's an elegant solution to a common challenge, which ensures that the AI models are not just accurate but also response, and it's very quick to deploy. Coming to asynchronous mode is it's about there are two things. It's about doing two things at once efficiently. While your device processes one frame, your application is already preparing the next one, as you see. And this overlap speeds up the entire workflow, and it's a brilliant idea. If you see, imagine a video processing task. Traditionally, each frame in a video, it's decoded. This is a very intensive process, and many of you have already worked on this, will know how much of time it takes. Asynchronous mode, it's the job is just not to make the AI load work faster. As I mentioned, it works smarter. It ensures that the overall frame rate is determined by the slowest part of the pipeline, not just the cumulative time of all processes. And this is very, very critical in real-time applications where every millisecond count. As I mentioned, we saw earlier, right? 26 millisecond got reduced to 2 millisecond, and that speaks volume for some of the enterprises and businesses. So the code snippet for asynchronous mode looks like this. So I'll try to quickly wrap up. This is our performance. We have some of the performance tricks. Again, if you want to deep dive, you can scan the QR code. This is for the throughput mode. The key strategies include, optimizing batch sizes for any device and adjusting the number of inferences thread for CPUs. And there are like many other tips that you can follow to, get the best performance. Now, this is another topic. We spoke about optimization, optimizing the model, and so on. We humans are greedy, right? If you want further performance, in spite of optimizing your model, then quantization is the answer for that. What it means is, I'll show you through graph. We are trying to further reduce the precision into int8 format. I'll try to explain it in simple terms. This is a visual image. I'm sure you must be thinking that it's the same image on both sides as I showed before. Can you spot the difference? Like, I've already mentioned it in words here. You can clearly spot the difference if you look into the right and left image. The one that is has better clarity has 16 cross numbers of colors, whereas the right one is has lesser quality, but it still conveys the fact what the image wants to convey. There is a man standing in a forest that has fire or bright light, but the difference is it just has 16 colors to it. So that's what quantization means. So we are trying to reduce the model, which is in FP 16 or 32 format, to int8 format, further reducing the precision. And so we are further simplifying the model and make it run faster. So there are many algorithms that we use depending on what kind of model you use, what is your end goal, the requirement, and so on. One of it is weight compression, which is a smart strategy for models, particularly that is crucial for memory-heavy large language models. Today we call them LLM, the most popular ones like the Llama 2, ChatGLM. If you're familiar with ChatGPT, the brain model behind it is an LLM. So by compressing weights, we can fit large models into limited memory spaces. And, the neural network compression framework, or NNCF, facilitates this with 8 and 4-bit quantization. Focusing only on weights to maintain accuracy, while improving the performance as well. And this is what happens under the hood. The 8-bit quantization is akin to, efficiently packing your suitcase. And this helps to boost performance, and it is ideal for CPUs and GPUs as well. Not just that, we also have other quantization techniques like post-training quantization, which you can leverage. It can streamline the process for optimizing models for high-speed inference. This process involves evaluating the original model, transforming it into a quantized version. We try to export both optimized and original model to OpenVINO IR format and comparing their performance. And this is what happens. What we try to do here is try to utilize minimal data set requirement for post-training quantization, and thereby reducing the need for extensive data and simplifying the entire process here. So we also have accuracy control quantization, which involves, fine-tuning 8-bit quantization while monitoring the accuracy of the model. Most of them does that, and it requires both calibration and validation data sets. What we do is, with the validation set used, we ensure that the model accuracy is intact, and it is compromised during quantization. We ensure that it isn't compromised, because one thing that all of us want to know is, we keep telling that we are optimizing the model, quantizing the model, like further making the model lighter, right? So there should be this question that pops in your mind, asking, are we compromising on the accuracy? And the answer is yes, but it's very, very negligible. You will see why. I'll show you the numbers soon. So coming back to our, star player, neural network compression framework, or NNCF, if you're a developer, you're using OpenVINO model or TensorFlow model, or in any of this format, you utilize what I briefed, the algorithms, one of these algorithms, you quantize your model, so your neural network gets simplified to this. You see the nodes reduction in the layers and nodes. And so you make the model, lighter and run faster with just pip install NNCF, which is Neural Network Compression Framework. As you see, we talked about compromising with accuracy, right? It's very, very negotiable. What you see in this graph is the dark blue is FP32 format, which is 0.76, and the lighter blue is 0.76. So we are trying to compare YOLO V5 model, and this is the mean average precision that we are showing here. As you can see, there is reduction, but it's very minimal, which we can afford to do. These are further examples of the testing we did on YOLO V5. As you can see, the accuracy is like close enough. And if you want to deep dive into any of these quantization techniques, post-training, accuracy, control quantization, or quantization aware training, please feel free to scan the QR code. And if these are all the tips that I wanted to give you. If you are looking at an optimization journey, these are some of the combinations that you can leverage to, actually build a business, the best business solution. And we have, so many of you would be familiar with Hugging Face ecosystem. So OpenVINO integration with Optimum is a huge step. We have OpenVINO integrated into Hugging Face through Optimum Intel. And the code snippet looks like this. So if you're using any of the Hugging Face transformer models, you can leverage Optimum Intel and skip most of the steps that I mentioned earlier. And this is applicable only for Hugging Face ecosystem. The red lines are the actual transformer code lines, and the green ones are Optimum Intel. So it's just few lines of change, a few lines of code, and you will have the transformer model optimized using OpenVINO, and enjoy the benefits of boosting the performance of your AI model. So as I mentioned, it's the convenience of combining Hugging Face with the efficiency of OpenVINO. So you get the best of both worlds. And these are some of the numbers. And if you want to install, it's again easy. If you're a Python developer, pip install Optimum Intel, and you'll be able to play around with all the popular models and see the performance in your very own CPU machine or the other machines that you have. So these are some of the code snippets that we have that you can explore to learn more about Optimum Intel. The quantization with NNCF in Optimal Intel again looks like this. As you can see, we are importing Optimum Intel and NNCF and applying it for quantizing a model to Infor format. So to the final, the answer to the initial question that I asked, if AI development and deployment, what is the major hurdle that we face, and what would be the solution? The answer would be this. It's a combination of software and hardware, and only with that, I guess we strike a balance and get the best goal out of what we wanted when it comes to deploying a model. And this is a quick high-level view of how Intel's AI software portfolio looks like. As a developer, you will pick and choose one of the devices from the entire spectrum that you see below. And you use some of our open standard programming models, leverage some of the toolkits that we have like OpenVINO, and build a solution which are currently being used by many of our ecosystem and customers and partners. So it's not just a theoretical thing. OpenVINO is being used by many customers and that you see here. And if you're a developer keen on exploring real world business solutions, industry based solutions, we have edge AI reference kits for you. There's smart meter scanning for manufacturing industry, where you can just scan digital or analog meters and get the reading, which automates the manufacturing processes and improves operations multifold. There's also intelligent queue management, which is specific to retail industry, which enhances the operational efficiency at the checkout counter. So it tries to count the number of customers in a checkout lane, and automatically you'll be able to tell if you need a additional till or counter, or close the extra counters that you have used. By automating all of this, the retail customers or the business can save quite a lot, like a lot. And we also have defect detection with anomaly and many, many more. If you're really interested, you can scan the QR code and explore our Edge AI reference kit. And coming back to the OpenVINO notebooks, today, if you go to our GitHub and see, we have 140 plus demos comprising of LLMs, Gen AI, you name the model, you name any AI model, we have it. We try and support how you can leverage OpenVINO, optimize the model, and use it to build your own solution. So some of the popular notebooks are object detection. We have pose estimation, the video that I showed you in the beginning. And we have segment anything. We have YOLO V8, stable diffusion, which can convert text, simple text into stunning visuals like these. And many, many more Gen AI models like QR Code Monster, it's LLM, Lava, large language and vision assistant, which is like even better, text and image together, and you'll be able to create a chatbot out of it. The major recommendation would be, like, after the session, you go back and try it yourself, and leverage whatever we learned today or explored today. And if you have any query, I'm always there. You can scan the QR code or connect with me on LinkedIn. And yeah, I'm sure today's session was really helpful, and thanks for the time. I really appreciate it, and I'm open for Q&A now. If you have any questions, please post it in the chat, or if you're going back and exploring, trying to install OpenVINO or any of our notebook, and if you have any questions, please feel free to connect with me. I'll be happy to help. So I can give few moments for you to, ask questions. In the meanwhile, if you can scan the QR code and take the survey, that'll be really helpful.
Anisha, thank you so much for your talk. It was certainly very, very interesting. And I think we all got an experience to learn more about OpenVINO and what we can build with it. It will be fantastic if you can also share some of the links that you can share, so that you can also add them in the Slack. So anyone who wants to learn more and download the software, they can do so. And I would like to remind everyone that we're going to have a follow-up session with Anisha, a more practical session with Anisha on the 6th of February. So Anisha, would you like to tell us more about the next session and what we're going to do there?
Yeah, so I wanted today's session to be on a lighter note, so that I'm introducing the toolkit OpenVINO and what it does. We saw how important it is to optimize the model even after developing a model. But when it comes to AI, we are advancing so much on a daily basis. And if you see, almost most of the businesses are adopting to Gen AI. Generative AI models and large language models. So I would be, deep diving into where are we at Gen AI? How can you leverage Gen AI models and build real world solutions, and especially optimize those sophisticated models. Few years back, you'll be able to experiment or even test a Gen AI model only if you have a GPU or a sophisticated hardware. But today, with the advent of these technologies, you can even run it on edge devices or your own CPUs. And that's what we are going to see on our next session. I can ensure that it is going to be visually stunning because it's Gen AI that we are going to see.
Sounds fantastic, and I'm personally very interested, and I really look forward to learning more from you how to use OpenVINO and turn text into visual stories. I don't know if there are any questions, but Anisha, I would like to thank you again for being with us today. Thank you for taking the time and sharing all your knowledge with the community.
Yeah, thank you so much, Maria. It's a pleasure for me to connect today, especially help women developers. It's exciting to see them exploring all of this. So even I'm happy and glad to connect. Thank you very much. Thanks all.
Great. So thank you, everyone. Thank you for participating today. Just a reminder that we have the meet and greet event tomorrow. So join and let's get to know each other and let's have some fun. And of course, the follow-up session from Anisha on the 6th of February. Bye, everyone. Thank you for being here today.
Thank you. Bye-bye.
Thank you.